go over a couple of these homework problems first. Okay, so number 9 on the back. Number 9 was, if I have two roots that are 3i root 2. Kayla, why? Thank you. Always. Why does it do that? I don't understand. Okay, x and x. And so one of them is going to be positive, one of them is going to be negative. 3i root 2, 3i root 2. What do we call this when we have a plus and a minus and everything else is the same? Difference of two squares. So what goes in this one? X. What goes in this one? 3i square root 2. So I'm going to square everything inside of here. X squared. And I'm going to square everything inside of here. 3 squared, I squared, root 2 squared. See, it's really quite easy, right? So this is x squared, negative 3 squared is 9. I squared is negative 1, right? I squared is negative 1. Remember our whole box? And if it's negative 1, we could call it I squared. Or we can do it in the reverse too. If it's I squared, we could make it negative 1. Okay? So it's negative 1. So instead of writing negative 1, can I just make this positive? And root 2 times itself is just 2. So this is x squared plus 18. Not that hard? Can you do that tomorrow? Let's do another one.
No, I think I can.
I like it. Plus or minus 4i root 5. So I give myself two roots, right, equal to 0. So this becomes x and minus and plus, or plus and minus, doesn't really matter, and 4i root 5. 4i root 5. I should have been color coding these. Okay, so if this is the difference of two squares. The difference of two squares means I take the first one and put it inside of the first square, and the second one and put it inside of the second square. Then I just square them. This becomes x squared minus 4 squared. This gets squared, this gets squared, and this gets squared. I squared and root 5 squared. When I do that, I get x squared minus 16. I squared is negative 1, which makes that positive, and root 5 times root 5 is just 5. And 16 times 5 is 80. Why? There it goes. Plus 80. Thumbs up, thumbs down. Awesome. I got everybody thumbs up. Okay. Can you guys do this? Let's set the timer for 5 minutes. Do everything you possibly can do on your desks, please. Thank you. 5 minutes. I heard really great conversation as you guys were doing this. I'm going to go ahead and do it for you. Okay, so if I were to factor, I would see that I have a 10 in common here and a negative. They both have a negative, both have a 10, and they both have an x. So I'm going to factor out negative 10x, and I would be left with positive x plus 2. If I want to double check that, I would just say, what's negative 10x times x? Negative 10x squared. What's negative 10x times 2? Negative 20x. So I just checked my work. Uh-oh. All right. From that, I have two things. If this is all equal to 0, which is what we want it to be, we want y to be 0. We're trying to find roots, right? So we want the y-axis to be 0. So we're going to say this is 0, equal to 0. I would say y is equal to 0 when x equals -2, correct? And y is equal to 0 when x is equal to 0, because there's nothing with that one. And we can find that by saying x plus 2 equals 0, which gives me x equals -2, and -10x equals 0, which gives me x equals 0. But I don't want to write all that work. I just see the fact that there's nothing being added or subtracted to that, so it's just 0. This one, the opposite of +2 is -2. So that's all we do. Correct? I need all of the pens to be shut, and you're just watching me. All right? So now that I have that, I'm going to go over here and graph that. I've got at -2 and at 0. Well, we learned what the axis of symmetry is from that. It's right in the middle of it. I learned something today. Remember our whole relationship, our direct relationship between the distance here? What did we say about the distance there? That we square it and it gives you the vertex, right? So this distance is 1. So 1 squared equals 1. I know my x is negative over here, right? -10x squared. Let's just write that. -10x squared. So since this is negative, I know it's going to be going down. So I would go down 1. Sorry, not down 1. I'd have to go up 1 because that would make the wrong graph. How many of you did it that way? That you said that my axis of symmetry is -1. So if I take -1 and square it, I get +1. So my axis of symmetry, or my vertex, is going to be at -1, +1. How many of you did it that way? 1, 2. Okay. So I learned something this morning. Okay, it's wrong. But it's not, the idea of it is not wrong. There's just one piece that was missing, because we've been double checking it over and over again, right? And it's been working. The problem is each time we are double checking it, we always had a coefficient of 1. So somebody tell me what the real vertex is. -1, 10. So do you guys see the relationship? I squared 1 and got 1. But what was I not considering? Times it by the coefficient. Exactly. Does that make sense? Okay, let me show you in a different sense, guys. If this was a normal, if this was just 1x squared, then it would look like this, right? It would be a normal graph. That would be perfect. But it's not. It's going up at a rate of 10 times. So if this shoots up, this vertex shoots up to 10, the graph gets skinnier, right? As it's, the bigger the number is, it gets skinnier. Can you imagine it going skinnier, right? Skinnier, skinnier, skinnier. This part's going to shoot up. Like if I were to squish the graph, the vertex is going to rise up, right? Does that make sense? So that's why when you have a rate of 10, it's going to shoot up by 10. So that still works what we've been using, where you just square the distance. But after you square it, you've got to consider the fact if you have a coefficient there or not. So if that was a 4, you'd square it and multiply by 4. Okay, makes sense? Better? Okay. I was really upset. I spent all the first period, because Miss Wiz did this one, and she's like, let's just square it. And she's like, wait a second, that doesn't work. I'm like, why doesn't it work? It's worked with everything else we've done. And then after class ended, we looked at it, and we said, oh, there's a relationship here. It's 10 because the coefficient is 10. Okay? Yes. Yes. Coefficient, I always remember coefficient as co-captain. We're always talking about x squared. So who's x squared's co-captain? -10's his buddy, right? He's attached to him. Okay? Coefficient's the one in front of the variable. Okay, you're very welcome. All right, let's finish this off. So, let me erase this. Erase. I don't even know what I'm erasing. Oh, it's right here. Okay. I want to erase the green one. Okay. So instead of it being at negative 1, 1, it's going to be at negative 1, 1 times 10, which is up here. So that's going to be my graph right there. We always want to make sense of it. All right, I'm going to do it with the quadratic formula very quickly here. Let's do the quadratic formula in purple. Black, so I can fill stuff in. All right, so my quadratic formula is finding roots. X equals, Lucas said, well, Mrs. Mahler, I got the same roots when I use the quadratic formula. Of course you're going to. You should get the same answer in each one of these boxes. Oh, you used a factored one instead of this one. They're the same thing. They're exactly the same thing. All right, so X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Put my B in there first. My B is, sorry, that's my A. Here's my B, negative 20. So put negative 20 in there. My A is negative 10. So that goes here and here. And I don't have a C. There is no C. Well, that makes this number a lot easier. Okay, let's finish this off. So, X equals negative 20 times negative times negative 20 is positive 20, plus or minus. The square of 20 is 400. 400 minus nothing because it's all multiplied by 0, so it's nothing. We'll shorten that up a little bit. All over 2 times negative 20 is negative 20. I'm going to go ahead and start simplifying and splitting right now because this says to me I've got an axis of symmetry and it's being added and subtracted by a number to get to my roots. So I'm going to say X equals 20 over negative 20 plus or minus 400. I'm going to break 400 up. I don't know what the square root of 400 is, but I know that 400 is 4 times 100 over negative 20. So X equals negative 1 plus or minus. The squares in there are 2 squared and 10 squared, right? 2, so 2 comes out and 10 comes out, so you just get 20 over negative 20, which ends up being negative 1 plus or minus negative 1. I had a teacher tell me today, or was it yesterday, that they would, if they were given a choice, they would always use quadratic formula. I'm like, why? There's so much room for error. Wouldn't you want to use the method that makes the most sense to you and like pulls the information out that you can see? What I'm going to show you today is the method that I love the most. When you get your test next week, you will get to, actually your quiz tomorrow, your group quiz, there are 4 problems on the front, and you can use any method you want. Whatever method makes the most sense. You could factor. If it's not factorable, you could, what? You could graph it and make sense of it. You could use the quadratic formula. And today I'm teaching you completing the square. But that wouldn't give you the roots. Okay, so let's move on. All right, so you actually already know how to do these already. You should automatically be able to tell me, what do I do with this to solve? Take the square root of both sides, plus or minus square root of 3 squared. So it would be X equals plus or minus 3. What about this one? Same thing. I would take the square root of both sides, which is plus or minus 3 squared. which is x minus 2 equals plus or minus 3. And at this point, most teachers would say, okay, I've got two solutions. It's x minus 2 equals negative 3, and x minus 2 equals positive 3. But I don't do it that way, because I think of it graphically. You can do it this way. I think of it like this. X equals positive 2 plus or minus 3, because this is your axis of symmetry, and you're adding 3 to each side of it. That gives you your roots. It's the same thing, right? It's exactly the same thing. Okay, so that takes us to today. You actually already know how to do this one as well. You should be able to just look at it and solve it right here. What do you think goes in here? It's definitely an X. Plus or minus? It's a perfect square trinomial. I'm going to teach you today how to do that in your head. Yes. So now, it's the same problem as this one, isn't it? Isn't it exactly the same problem? It's just a different form. It's exactly the same problem. It's exactly like this problem. It's x equals an axis of symmetry of 2, and I'm going to go to the right 3, and I'm going to go to the left 3. And now you've got it graphed. Then you can figure out your vertex, right? Immediately you can figure out your vertex. Let's see. I'm taking out like a lot of the algebra. It's like we're mixing the two. So I would be at 2. I would be at 2. That's my axis of symmetry. And I would go over to the right and to the left 3. So 1, 2, 3. There's 1, 0. 1, 2, 3. There's another 0. What's the relationship? If I go over 3, I'd have to square 3, which would be 9. Do I have to multiply it by a coefficient? Nope. Is it going to be down here, or is it going to be up here? Down, because your graph is positive. All of that just by making sense of a problem. Okay? All right. So let's figure out how to find perfect squares in our head. They're actually right in front of you if you think about it conceptually with a picture. Because it's a square. I wonder why they call it completing the square. Because you're completing. No, it's true. Like, people don't realize why they call it completing a square. You are actually completing a square. Okay, so here is x squared plus 4x plus something is going to complete this square. All right? 4x's. If I call this, if this is my x squared and these are my x's, don't I have 4 of them? All I did was split them in half. I took my 4x and I split it and I said, okay, that means I've got 2 x's on one side and 2 x's on the other. So if I want to know how much I have to add to complete my square, I'd have to add 4. Or 2 squared. Now do you see that this is an x and this 2 goes here and the square is on the outside? I am going to repeat that whole thing again. Okay. Because isn't this what we had in the previous? Well, I guess it was almost like it. Right? We saw that? Well, I don't look at it like this. I look at it like 4 x's. I need to split them in half. That means I'd have 2. And then I would square it, and that makes my perfect square binomial. I have an x, and it's almost like the whole difference of 2 squares things that I was showing you earlier, that you've got, right? Remember that? And we put the first one and the last one like that. Kind of like that, but not exactly. All right, we're going to practice this together. Questions first. Carrie, I told you off. Yes. It is, but that's only with this problem. Okay, so now we're going to see if you guys can split. That was just for other teachers to see. Okay, so I'm going to show you how I'm going to do this graphically. So I want it to be pretty. All right, so I'm going to show you how I'm going to make that picture really, really quickly. I have an x squared. I have 4 x's. I'm going to split them in half. 2 x's and 2 x's. What do I need to complete the square? C is going to have to be, let me change my color. C is going to have to be 2, which is right here, 2. And I've also got another 2 over here. So what do I call it when I've got 2 of them? Squared. My perfect square binomial is going to be x plus 2. Let's double check. X squared plus 4x plus what makes a perfect square binomial? Let's see how many. 1, 2, 3, 4. Is it 2 squared 4? So in essence, these two things right here are exactly the same thing. They're just in different forms. All right, you want to see another one? No. I'm going to show you. You're going to be able to do it in your head. Once we do this with pictures, you'll be able to do it in your head like that. Okay, so I have an x squared. This time I have -8. So to make negatives, I'm going to make squiggly lines. Okay? So I have, how many am I going to have on each side of my square? 4. 1, 2, 3, 4. 1, 2, 3, 4. So that means that C is going to have to be 4 squared. So my perfect square binomial must be x, and it's not +4, it's -4, right? Because they're squiggly. X minus 4 squared. What would that look like over here? X squared minus 8x, what would this have to be? 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Oh, so you take half of the answer.
Try that one. Or this. This is what we're looking for, guys. I need this number squared, and that would make it here squared. I hear 2. You know from right here. So x squared is an x squared. I have 2 x's. I'm going to split them in half. There's 1 x. There's another x. So what would complete that square? 1 squared. Or just +1. Let's double check. Over here it says x squared plus 2x plus how many would complete the square? 1, because 1 times 1 is 1. Nope, we're gonna go there too. You guys want to try another one? What about that one?